Let's talk about solving a system of equations with 3 variables. I'll take us through this example. Now this example, what we're going to do is we're going to transform this into a system of equations that has 2 variables. We know how to solve those. We've got substitution and elimination. So once I get down to 2 equations with 2 variables, we'll be home free. What I'm going to do that is eliminate one of the variables 2 different times. So I'm going to decide which variable seems like it's the easiest one to eliminate. Looking at this, I like the y's because I could eliminate the y in my first equation by using the y in the third equation pretty easily. And then the same thing for that second equation. I could eliminate the y in the second equation by using the y in the third equation. We're just thinking elimination here, and we're combining any of the 2 equations together to eliminate the same variable twice. Since I can easily use that third equation to eliminate the y in the first and the second equation, I'm going to call that third equation my master equation, and then the first and second I'll just call 1 and 2. So now what I'm going to do is I'm going to take that master equation and I'm going to use it to eliminate the y in equation 1 and in equation 2. So let's start with equation 1. If I want to eliminate y from equation 1, I'm going to add these 2 equations together and I want the y's to cancel. So that means all I need to do is multiply this y so that it is a negative 2y. Then it will be the opposite of the positive 2y in that first equation. It's already negative, so I just need to multiply it by 2. So I'll multiply the entire equation, everything on the left and everything on the right, by 2. So my master equation now becomes 12x minus 2y plus 8z equals negative 6. And my first equation, I don't need to change because I already have that positive 2y. So I'm just going to take that first equation and write it down below, and then I can add the equations together. So since I have those additive inverses, I add, and those y's will cancel. So now I have a new equation with only x and z, the y's have canceled. I'm going to do this again, but now I'm going to do it with the master equation and equation number 2. So now my question is, what do I need to multiply that y in my master equation by to get the inverse of the y in equation number 2? If I want those to be inverses, one needs to be positive and one needs to be negative. So I know that I need to multiply this negative 1 here by negative, and if I want it to be 3, I'll multiply by 3. So I'll multiply the entire equation on both sides, left and right, by a negative 3. So then that new equation is negative 18x plus 3y, just like we wanted, minus 12z equals 9. And then I take my second equation and I just write it below and I will add. So these 2 equations that I have now, I'll call them equation number 4 and 5. These 2 equations have the same 2 variables. So I'm going to go back to our old problems on solving systems of equations, and I'm just going to solve this one like normal. I'll go ahead and write equation 4 here, and then I will line up equation 5 right beneath it. So this one I'm just going to write directly beneath equation 4. And notice that I already have additive inverses. So I really don't need to do anything but combine these 2 equations and solve. 4z equals 8, which means that z is 2. So now we just work our way back up. I know what z is. I can plug this into any equation that has z and one other variable in it. So that gives me the choice of equation number 4 or equation number 5. Doesn't matter which one, whichever one seems easiest to you. I like equation 4. So I'm going to take this z and bring it back up to equation 4, plug it in and solve for x. So now I have x and z. All I need is y. So I can go back and plug it into an equation that has y in it, as long as the only other two variables are x and z, which of course they are, because those are the only variables we have in the whole question. So my favorite equation that has y in it, I think, is actually our master equation. So I'm going to take my z and my x and go all the way back up to this master equation and plug both of those in to help me find my y. So I've got 6x, which is negative 1 minus 1y, plus 4 times z, which is 2, equals negative 3. And then I just simplify and solve. So now I have x, y, and z, so I am done. How we write our answer is going to be as an ordered triple. So normally you have an ordered pair where you just have x and y, but now we're going to write it as x, y, z. So our solution is negative 1 for x, 5 for y, and 2 for z. So that is an example of solving a system of 3 equations. Hope that helped. Thanks for watching, and I'll see you next time. Bye.